Welcome to the HPC Best Practices webinar series. This series is brought to you by the IDEAS Productivity Project, which is part of the Exascale Computing Project of the United States Department of Energy. The series is a collaboration involving the computing facilities at the Argonne, Oak Ridge, and Lawrence Berkeley National Laboratories. I'm Osni Marquez from Lawrence Berkeley, and will be the host for today's webinar, Effective Strategies for Writing Proposal Work Plans for Research Software. And the webinar will be presented by Chase Million. Chase is the founder and CEO of Million Concepts, a company that provides research software engineering and research support services, in particular in the fields of planetary science and astronomy. He has almost 20 years of experience in the field, and he has written mission support software for a number of NASA missions, including the Mars rovers and the Galaxy Evolution Explorer Space Telescope. He has worked as a software project manager and served as a PI on multiple software-heavy grant-funded projects. Chase is one of the 2021 Better Scientific Software Fellows, and he's an advocate for open source software, open data, and high-quality research software and data archiving. Related to this webinar, there is a podcast that Chase produced. I'll paste the link to that in the chat momentarily. We have issued 100 plus tickets for today's webinar, and all attendees have been muted upon entry. We'll be receiving questions through the Zoom chat and also Google Doc. I'll be reading those for Chase. With that, Chase, please. Stop my sharing.
Hi, hello. Thank you, Osni, for the wonderful introduction. I'm Chase, and I am associated with all of the facts that Osni just reported about me. This is, as he said, a work product from my Better Scientific Software Fellowship. The major work product of this is a 50-page document that goes into real detail on all of the things I'm going to cover today. There's too much for me to cover in an hour. So this is just a teaser, and I'll have a link to that document at the end. Hopefully you go look, you read it and find it useful. So first of all, here's just my bona fides. This is basically what Osni just said. I'm not in the field of in the domain of the national lab, so most of you are not familiar with me. This is perhaps evidence that I may know what I'm talking about, although I'm not 100% confident in that. So what we'll be discussing today is how to write work plans for proposals. And this is based upon a thesis that I developed over 10 years of writing dozens and dozens of proposals which failed, and eventually hitting on a formula that led to a string of proposals disproportionate to the statistical likelihood of those being successful. I should also say, please interrupt me with questions at any point. Type them in the chat. Osni will break in. I'd love to be distracted by questions. So the thing I observed is that as both a writer and reviewer of proposals, most scientists don't have a background in systems engineering, project management. And as a result, proposal work plans in particular tend to suffer. I've written many proposals, been a co-author on many proposals, and reviewed many proposals where the work plan ended up taking maybe 2 pages of the 15-page allotment. And that fact always comes up in the review. It always ends up being a ding on the proposal, which makes sense because you're asking for a tremendous amount of money to do something. And it's reasonable for the funding agency to want to know what you are going to do with that money. Rarely does it come up in proposals whether the work is worth doing. If you are a scientist and you have a position in an organization that allows you to write proposals, it's sort of presumed that the things that you want to do are things that are worth doing, that you are solving real problems and addressing real needs.
Chase, just it seems that your sound is a little bit low. The microphone.
Is this better?
Let's try it.
Is this better?
Yeah, keep going, please.
Okay. So the whole secret is that there's not a secret to writing a good work plan. You just have to have a plan. And like I said, because many of us were not trained in these things, we don't have plans to describe. So again, over years of failures and reading a stack of books that I'll refer you to at the end of the presentation, I learned how you make such plans. And in particular, I learned that for the type of work that we tend to do, the plans aren't really that complicated to know how to go about creating. You still have to do a lot of work to create them, but it's rather simple to understand the basic principles of making the plan in the first place. Some of those, so the key steps are you have to scope the project, you have to know its boundaries, you have to know what the requirements of the project are, you have to make an estimate for the project, so how much resources will it take, and then you have to make a schedule for the project, which is how is the effort going to be distributed over time. Some of the key observations that I made while digging through the literature on scoping and estimation for projects is that, again, in our domain, so what I'm talking about tend to be smallish research projects, so like less than 5 people, maybe less than a few $1 million. There are estimation strategies that work very effectively in that domain that are easy to grasp. It is also possible for us to sort of play fast and loose with project management roles and standards, and that has to do with the nature of sort of fundamental research. I go into this in great length in the document, so if you question me on those things, you should read my full argument first. And the basic principle, the basic idea of estimation here is something called task decomposition, which is to say you break up the project into smaller projects, smaller tasks. Each of those in itself is easier to estimate. You estimate all of those, and then you assemble them all back together in the end to make a final estimate. So I'm going to quickly run through all those steps. Again, I can't explain this in just 45 minutes, but there is a document to refer to. So the first step is to create a vision and a scope for your project. That is, what is it we are trying to do? This should be a statement, maybe a few sentences, not more than a paragraph, that all of the stakeholders of your project, that is the people you're collaborating with, the people who will actually be doing the work, the technical people, everyone should agree, this is the thing that we are trying to do. And this should be the foundation of your whole proposal and your whole estimation project. This is surprisingly hard to do. Many people skip this step. It's very easy to write a sentence that 2 people read and take completely different things away from. So you will have to get everyone in the room and really iterate on this and make them explain, what does the sentence mean to you? What does the statement mean to you? Make sure everyone's on the same page with the vision and scope. In business context, which is where I've gotten a lot of my training, this is sort of equivalent to the elevator pitch. That is, you're stuck in an elevator with someone who's going to invest in your company. You have 28 seconds to sell them on your company. This is the statement you give them. If your elevator pitch is not good, as in business, as in a proposal, then the project is probably not very well scoped, and it's going to be hard to sell as a proposal. The second step of scoping and estimation is something called a concept of operations document. In formal project management training, this has a real meaning. It's defined in an IEEE standard. I mostly ignore that for these purposes because within a smallish research context, usually that level of precision is not important, and those documents were written for industrial contexts and large projects. Basically, how you create a concept of operations document is you interview the users of your software. This would be some fraction of the stakeholders, the COI and the PI if it's a small research project, the grad students who might be using the software. And from their perspective, get a sense of what is the current situation that is trying to be solved by the software. What are the critical features of the new system that need to exist for a solution? You'll get a bunch of different perspectives on this. There's probably not a solution that exists. In that case, you need to explain the context in which people have worked around it. Maybe they've made prototypes, maybe they've had hack solutions that they've implemented for years. A lot of the work we do, we take software that's been around for 30 years, and then we refactor into something more modern that can be better maintained. In the same document, you want to describe the proposed system, and then pass that document around to everyone you've interviewed and make sure that they agree that you've represented them fairly. Again, it's a short slide, what is it, 5 bullet points. This is a really hard thing to learn, how to talk to users and understand what they really need, what their real problems are. And I do not have a quick way of conveying that. But where I learned it was in technology startup incubators. This is a technique they teach that they call customer discovery, which is that you go out in the world and you talk to people who might be users of your product, and you figure out what their pain points are so that you can solve them. So if you want to go try to train yourself from textbooks how to do this sort of thing, look into things like, I think there's a document called Talking to Humans. There are various startup manuals for how to do this sort of customer discovery thing, but the best way to learn is to just do it a lot. The third part is requirement specification. So a requirement specification document is, again, a formal IEEE standard, and I have it referenced I have the exact number referenced at the end of the talk. It's very useful to read that document. It contains a lot of useful information, but again, the formality in the context in which I'm talking about is probably less important. Basically, what a requirement specification is that it is a list of conditions such that if all of them are met, the project vision and scope will be achieved. The categories of what makes a requirement can be a little tricky. So a requirement is what the software must be, not what it must do. So at this stage, you want to be careful not to instantiate technical solutions as requirements. So unless writing your software in Python is a real requirement of the job, like it's in your contract, then the language in which you write the software is not a requirement. Another example I use is the difference between a software that displays an image and image display software. The second one is not a requirement, the first one is a requirement. It's a little tricky, but once you get the hang of the difference between a requirement and not, it's very useful, and it will also save you pain down the line trying to build the wrong thing. Once you've made that list, you should rank the list. I usually rank the list based on speed to minimum viable product, but you can rank the list upon many different axes. And you should also categorize everything in the list as a critical requirement, a stretch requirement, and a nice to have requirement. And then cross out everything that's stretch and nice to have, because by definition, those are not requirements. Again, that's a problem I see a lot, and that I used to do a lot, is dragging along a bunch of requirements on my project that are not real requirements. You'll save yourself headaches by not doing that. And finally, the accuracy, the completeness of your requirements document is going to form the foundation for the estimation. So if the requirements are not complete, the estimation will be wrong, and it can be wrong quite badly. So in service to that, here's a list of common software requirement categories that you should review and make sure that you're hitting all of these when any that are necessary when you're doing your requirements. I go into more detail on these in the document. Many of these are defined in the IEEE standard as well, and I won't go through all of them, but you should use this as a reference. We in my company use exactly this list when we're making requirements to make sure that we've hit everything. So having done scoping, we've established the boundaries of the project and the requirements of the project. It's time to get into the estimation part. So like I said before, the strategy we're using for estimation is something called task decomposition. And in service to that, we are going to build something called a work breakdown structure. These are terms of art, and I've fiddled with them a little, but these are terms of art you should be familiar with, and you can search these terms to learn more about them. The steps to creating a work breakdown structure are, first of all, figure out a technical solution. So up to this point, you should have avoided the temptation to commit yourself to some specific technical solution. At this point, you should pick one. You may pick a few, find the one that you think is most likely to lead you to success. At this point, you can always revisit this step. Given that technical solution, break the solution down into tasks and subtasks, each one of which should be small enough, but no smaller, that you can conceive of doing it. It is not important at this point that you actually know how to do it, but you need to look at each task and say, I could probably do that, or this person on my staff could probably do that. They all need to be what I call achievable goals. I love achievable goals. It's my favorite kind of goal. In any project, again, at the scale we're talking about, I would suggest maybe 10 to 20 of these. If it's a big research project, maybe 40. If you have too many, if you've gone too fine in resolution, maybe your project is too hard, or you've just decomposed too much, but you should resist that urge as well. Also, even though you have a technical solution at this point, avoid making any unnecessary technical solutions. If there are things that you can leave open-ended at this stage, do, because later in the project, when it comes time to implement those things, you'll have a lot more information and a lot better basis to make informed decisions about how to do that stuff. And then again, the quality of your estimate will rely inextricably on the completeness of your work breakdown structure. To that end, here's a list of commonly forgotten task categories that we use within my business when we are doing these estimations to make sure we've hit everything. I won't go through all of these, but you should use this as a reference. There are lots of things that are commonly forgotten that will really eat up a lot of time. And if you forget them, then you'll be in a bad place. One of them, for example, is just IT management, like even merely updating the virus checker on your computer, or backing up data, writing documentation, communicating with end users and customers. Those things all in fact take a lot more time and can sometimes rival the actual development work in the amount of time that they take. So now onto the estimation. You have a work breakdown structure that is all of the tasks, such that if all of the tasks are completed, your requirements will be met and your project will be completed successfully. For each of those tasks, go through them one by one. For each of them, make an estimate in terms of billable hours, that is the number of hours you'll actually spend doing the work, of what it will take you to complete each task. When possible, the people who are going to do this work should be the ones making the estimate. There may be a few exceptions, like if you're working with new grad students who don't have a lot of experience, they might not have a good basis to make these estimates. But if you're working with career professionals, those are the people who should be making these estimates for themselves. They will be in the best position to judge. For each of those time estimates, so you've made an initial time estimate. Let's say the task is bake a cake and it's 2 hours. For each one of those, then assign a confidence factor. The confidence factor is going to be chosen from 1.2, I'll explain why in a minute, 2, 3, or 4, where 1.2 is the most confident you are in your ability to achieve that task, and 4 is the least confident you are. So you will now have a new column where every estimate that you initially made is given a confidence factor. So let's say we're baking a cake. I think it will take me 2 hours, but I think I've baked 3 cakes in my life, so pretty sure I can do it, but it might get a little hairy. I'm going to assign that a confidence factor of 2. Now, for all of your tasks, you have there's 2 things you can learn from this. First of all, if you sum your initial estimates, so that would be 2 hours in the case of the cake, that is your best case scenario estimate. So that is the amount of time that you might expect the project to take if everything goes exactly as you expected, because those are the conditions under which you made those initial estimates. If the project does not have as many resources as that indicates you will need, then the project is probably, in my opinion, doomed to failure, and you should either try to get more resources or change the scope of the project. The other thing you can learn from this is by doing a pairwise multiplication across the initial estimate and the scale factor, and then summing that. That produces what I will call the project estimate. This is the amount of time, of resources that are likely reasonable and sufficient to achieve the project objectives. Again, there are a lot of caveats in that, a lot of things that can go wrong. If your requirements aren't complete, it's going to be wrong. If your work breakdown structure is incomplete, it's going to be wrong. But in general, this is a reasonable first estimate. And I also know, if you haven't seen this method before, that you're probably thinking it seems like I made it up and it's complete BS. But I assure you this has real basis in the literature of project estimation. And also it works. We use it in my company. We've been using this method pretty consistently for 4 years, and we've had very good success with it. The only time while using this method that we've had a project run over was because I did not follow my own advice and allowed the estimate to be negotiated down from what it should have been. If we'd taken the resources that we needed to do the project, it would have been successful. So it sounds magic, but I promise it works. So let's talk about those scale factors for a second. 1.2 is, so you might think of that as like a 20% increase of your initial estimate. The reason for this is because everyone underestimates everything, even experienced estimators, even experienced software engineers. Everyone is more optimistic consistently about the time it will take them to do something, even something they have done precisely the same way before. So for that reason, we tack a 20% margin onto even the best case scenario. A category 2, uncertainty factor 2, is for things in which you have deep domain expertise. You may have done something similar, but not something exact. Most things in a research project will fall under a 2. There's a lot of tasks like communicating with clients and doing IT work that will just fall under 2, because those are things you've done before or done similar enough things before. The really hard work for most research projects tends to be a Pareto distribution. You'll have a few things at a 4. Most things should be 1s or 2s. 3 is just somewhere between 2 and 4. And then 4 is a task for which you're confident that you can succeed, but you have no idea how. So that tends to be the real meat of the research project. If there are algorithms that you need to work out, if there's hard optimizations that you need to do, all of those things will come under 4. And again, I know the people doing the work should be the ones who do this. And I caution all of my employees and everyone that when you're doing this, think about yourself, how you will do the work, how long it will take you, because we tend to compare ourselves to others, and other people would do it faster or better, and we think we should be able to do that. How long it would take someone else is irrelevant and should not enter as a factor into this at all, unless you can hire those people. And then by all means, hire someone who can do it faster. Here's an example of this. This is an actual estimation. It's a clip from an estimation document that we produced in my company for a contract. You can see we have descriptions of the tasks. This is from our work breakdown structure. We categorize it under this specific deliverable, and then we have all the tasks therein. Some of those things are communicate with the customers, like there, write documentation, follow on bug releases. And then we produce time estimates for each of those tasks. In this project, we had some repeating tasks, so we included an items column, and then we assign the uncertainty factor to all of those tasks. We add them up, and this is the project estimate. That is the basis of the quote that we gave to the client in this case. We also tend to have a notes column, so we like to note in here if there's any unusual basis for the uncertainty factor. We chose, sometimes there are huge unknowns in the project, and like it could be a 2 and it could be a 4 depending on some specific the answer to some specific question. Sometimes we can get answers to those, sometimes we can't. Here's another example. So this was a much messier, a quick one-off within the company for a specific project, and it's the same sort of thing. The only difference here is we rounded the hours. I think there's enough uncertainty in this method that rounding to the nearest whole hour is not going to hurt the process at all. So this is just a summary of the estimation algorithm, which I won't read, but this is a good quick reference for everything that I just talked about on the previous slide. And then a few caveats of estimation. First of all, this is very important, and it's hard for a lot of people to internalize. The goal of an estimate is not accuracy. When you set out to create an estimate at the beginning of a project, this is not my realization. This is from the literature. When you set out to create an estimate at the beginning of a project, you were trying to figure out what the project will take at the time in the project when you have the least information about it. That problem is probably even worse in academic settings when you're writing a proposal at the sort of pre-proposal phase. You've probably done none of the work because you haven't been funded to do any of the work. So there's not even sort of a pre-work basis. There wasn't a pilot study. You probably have almost no information about how the project will actually go. On top of that, you might be pushing the edges of what can be known and can be done. So there's just all sorts of uncertainty there. If you are hoping you'll get a number at the end that says this will take 1,000 hours of work and then it takes 1,000 hours of work, you'll be disappointed. The merit factor of an estimate is whether it is useful. And for our purposes, it is useful if we are able to successfully request the amount of resources that are both necessary and sufficient for us to reasonably guarantee a successful project outcome. In some research contexts, that might not even be the thing you originally set out to do. In some it may, but the goal is to get the resources that you need and to have a reasonable basis for those. Second important point, and I talked about how I failed to do this a few years ago and suffered for it. An estimate is not the basis for a negotiation. So there's a trope in Star Wars where the captain, the Borg are attacking and the captain calls down the engine room and says, how long will it take to get to warp? And the chief engineer says it'll take 15 minutes and the captain says it'll 5 minutes, and then the engineer does it in 5 minutes. What I take from this is that the engineering team lies to the captain. I'm told that's actually Star Trek canon. Unfortunately, many people in our sort of domain have learned their management style from Star Trek and think that they can just negotiate down from the estimate. Resist the urge to do that. The estimate is the estimate. It came out of a fairly objective process. If it needs to be done faster, then something needs to change. If more needs to be done with the same resources, something needs to be changed. Also, the estimate that you initially produce is going to be wrong, the reasons I previously explained. So you should re-estimate pretty frequently throughout a project. You should certainly re-estimate when the conditions of the project change, if the final deliverable changes or some requirement has changed, but you should also re-estimate maybe 4 times throughout the project or annually or quarterly throughout long-running projects. And that is not to make sure that you are still on track with your estimate. Although it can do that, it can alert you very quickly to problems in the project as a whole. But it is to allow you the opportunity to change things in the project so that you can still get within the estimate cap. So you might have to change your technical approach. You might have to request more money. You might have to change the final deliverable. But you will never know those things unless you go through this whole exercise again mid-project. And then the final thing, the thing I billboarded at the top of this talk is the point of all of this, is how to put this in a proposal. So all of this work is for naught if you cannot convince the review panel that you have a reasonable and sufficient basis upon which to request the funds that you're requesting to do the work that you want to do. And there are a couple artifacts that also come out of this project management literature that are very, very convincing to review panels. And I will go through those very quickly. First of all, I'll note that the work breakdown structure forms naturally section and subsection headings for a proposal. And that's how I've written my last few proposals. In fact, I've taken the WBS that we made during the project scoping, just made those section and subsection headings, and filled in exactly what we talked about for all of those tests, and adjusted accordingly to make it readable. But doing all of this pre-work will actually improve your experience of writing proposals, in my experience. And then there's a few graphical artifacts that I'll go into, and I'll note there is specialized software for doing all of this, but a spreadsheet program will serve your needs just fine unless you are really managing one of, a big research proposal. If you were building, for example, the most powerful supercomputer in the world, you probably want real project managers doing real project management, using real project management tools, and probably a different estimation strategy than this.
Chase, there is a question for you.
Sure thing.
How does this handle the situations in which your resources, people, are split between multiple sponsors projects? In particular, overhead, the overhead of context switching.
The overhead of context. So yes, it's like the same as task switching. Basically, you have. So for example, for me, I'm currently active on, we'll say, a dozen different projects, and on any one day I'll be working on, I'll touch four of those, and the ramp up and ramp down time between those two tasks is a cost, and someone needs to bear that cost who's not me, because that cost just exists. The estimation that I already covered itself does not take that into account, and it probably should, and I don't have a good answer for that. When you're creating the plan, which I'll go into in a few slides, which is to say the Gantt chart, you should take that into account. You should take task spin up and spin down into account. So that's a very good question. I don't have a good answer for it. If it's something you were really worried about, I'd probably just add like 10% to everything and call it a day, whatever you think a good ramp up and ramp down time is. Did I answer the correct question, Elton?
Yes, thank you.
Okay. I didn't answer, but I addressed the correct question.
No, the participant is happy.
So the first artifact is something called a task matrix. This just ties objectives to requirements. You can do something called a science traceability matrix that ties requirements to scientific questions or tasks to scientific questions. It looks like this. This is obviously just this is a mock-up of this kind of idea. But basically, for every requirement in your requirement list, you have a specific thing that your project will do, or things. There can be multiple tasks for one requirement, multiple requirements for one task, to which those things are tied. And this is a very good way to quickly convince yourself and also the review panel that everything that needs to be done will get done. You have a plan for doing all of those things. And there's a good document produced as part of a NASA training here on science traceability matrices for missions. So you can go here and get more information on that. The second artifact is called a Gantt chart. It was named after a guy named Gantt. It's not an acronym. The Gantt chart shows the distribution of work effort across tasks and time. It's essentially a schedule of work. Now, the time in this case is calendar time. So that's the thing I was just talking about. So when we do the estimate, we do billable time, and it's the amount of time you're going to bill to the project. That is almost never the same thing as calendar time. That is in part because many people in a research context don't work full time on any one particular project. You might only have half of their time or a quarter of their time. Also, there are critical events in any project that everyone has to wait on. There are things that have to be created as inputs to other things. So the project in calendar time might be 3-4 times the amount of hours in estimated time. The conversion between those two things is, again, very complicated, and there's no fixed formula, and it's just something you have to think really hard about. how do all things rely on all other things? But even without that, even without knowing how to do that, like you can create a basic Gantt chart pretty quickly. They look like this. I'm sure you've seen them. This is sort of my take on it. Also, I like to highlight what we have here. These are the number of hours assigned each task. This is the estimate. So that's the initial estimate times the uncertainty factor. So that's the amount of resources we're requesting to support this task. So the number of hours committed to the task is equal to the resources we're requesting. And then for each period of time, we have a total amount of work assigned to that period of time. So that's going to be across all people. And what I like to look for here is just that this is pretty smooth. Having big spikes in project output tend to be lossy, again, for that ramp up and ramp down reason, although sometimes it's unavoidable. And then I like to just, because reviewers like to pull out their calculators and make sure everything adds up properly. That's a gotcha I've seen from review panels. I like to include a checksum to make sure it's all correct. So here's a real project Gantt chart. This is for a project that we proposed that was successfully funded, and it shows all of the things that I just explained. In addition to that, we have task leads assigned each task. This is a thing that reviewers like to see. They like to see that someone is in charge of everything that's being done. Instead of hours here, I have fractional FTEs. The third decimal point in general probably doesn't matter too much, but because I wanted all the numbers to actually add up correctly, I used 3 decimal points of precision. But that's an example of that. Here's another one, which I know you can't read, but it's in the slides that were distributed, and it's also in the document. And then these are the things I already explained about just making sure everything checks out, because reviewers will pull out their calculators and double check you. So a few final tips for writing proposals. This first thing, in my opinion, is the most useful thing in this entire presentation. Even if you don't do anything else in this presentation, I think this will improve proposals in which you have had inadequate work plans in the past. And that is that the work plan should compose at least 30% of the page allotment. So many proposals ask for 15-page allotments, 15-page limits. 5 of those at least should be your work plan. It's absolutely okay to burn a whole page on your Gantt chart. That can be one of your 5 pages, but at least a third should be the page allotment. This is actually policy in my company. It is in our rules and procedures document. We do not ship a proposal anymore unless this is true. A second thing to keep in mind is that reviewers on review panels will tend to have 2 to, I've seen 15 different proposals that they are responsible for reading and reviewing. In order to do this, they've been taken out of their normal work lives. They've probably been possibly been flown to DC and are in an uncomfortable hotel with people they might not like. So they're exhausted and looking to get through this quickly. You should give them every tool possible to make their job easy. An important part of that is tables like the ones I just shown that clearly demonstrate what you're doing and that everything ties together and that you've thought about it carefully. Also, those charts and graphics should be big enough so that the text on the graphics is the same size, at least, as the text in the proposal itself. They should be easy to read. They should be easy to read when printed out on a piece of paper, which is, even in 2022, how many people read these proposals? I do. So again, it may seem like you're eating up a lot of your page count. With graphics, it's absolutely worth it, in my opinion. Also, verify that your charts, your graphics, and your text have consistent terminology. This is easy if you use the work breakdown structure as the basis for your section headings, but terms defined in your Gantt chart, for example, or requirements listed in your task matrix should also appear in the text, may be bolded so that it's easy for the reviewer to say, what is this thing in this chart? Oh, it's right there, now I know. They might not even read the description, they just want to know that you wrote one. And yeah, so those are the important things. I hit all of those. Finally, every proposal should have a Gantt chart. that's a hard rule for my organization. Task matrices we find to be less important, but if your project is very complicated, if the agreement between project objectives and tasks is not super clear, then it's a really important thing to have. That's why they have it on missions, because those are big projects with a lot of moving parts. Make sure every task is assigned to at least one team member. You can do that in the Gantt chart. I find that very useful, but it should also be explained in the proposal. That's the thing I've seen a lot of proposals fail on, is that not all named investigators or not all funded investigators have a specific job. And also not every job is owned by some specific investigator. If you've solved those dependencies in both directions, you'll be fine. And then finally, you have to assume that reviewers don't know anything about project management, because it's, again, not part of the training. So to that end, you will have to explain it to them. You'll have to explain to them that pairwise multiplication of an estimate of uncertainty factor is not merely magic. And for that purpose, in the document that I wrote, I have a paragraph of text. It is the paragraph of text that we use as the template at Million Concepts that we drop into proposals that explains very quickly, this is the method we use, it has a basis, this is why we trust it. To date, all review panels have accepted that. No one has accused us of not having a good basis for our work plan or our funding requests, or the thing I always fear someone's going to accuse us of padding. That has never happened. So you're welcome to use that paragraph of text as the basis for your own, and I suggest that you do. So quickly, we're in about 45 minutes, perfect. Here's some recommended reading. If you write software a lot for money, and especially if you ask for money to write software a lot, then I suggest you read everything on this page. Obviously, one of these things I wrote, but if you read only one thing, read the first book, which is Software Estimation, Demystifying the Black Art. This is like a classic in the literature for this. You can see how many notes I've made on it. This will go over the estimation method I discuss. It will go over many others. It will describe the situations in which those are and are not good. It's worth reading this book 3 times through if this is something you do for your career. The second book is called Software Estimation Without Guessing. There is a lot of repeated information between these 2 books. This one I find a little more approachable and more interesting to me. This one goes into a lot of the sociology of actually getting the project done. So it talks about more about the arguments you might have with management when you bring them an estimate for a 1,000-hour project and they say, can you do it in 800? How do you respond to those situations? Especially if you're a junior person and you're not comfortable pushing back, this will help, I think, give you the confidence to get the resources that you actually need to be successful. So there's a IEEE standard. I don't have a copy of it, but there are several books. This is one of them, the Project Manager's Guide to Software Engineering Best Practices, that break those down. So there's a lot of textbooks on this sort of thing, and those documents are worth reading. And then finally, the BSSW Fellowship document that I wrote. And then there was a previous presentation that I gave for the Open Planetary group, which is an international nonprofit that I helped co-found, that goes into a little bit more detail about the scoping and estimation part of what I've just covered. It's aimed at a fairly low level, so if you have some familiarity with those things, you might not gain much from it. But if you are new to these ideas, it's like a 35-minute whirlwind introduction. And then finally, I always like to include things that are not science and engineering. I think it's important for us to know the context in which we do things. So I recommend anyone who does research software development, anyone who's a scientist, read some of the sociology of science and technology studies. Has a lot of good work. This is a book that I like, Bruno Latour, Science in Action. May give you new, it's probably not all correct, what is, but it will probably give you some new perspectives on the type of work we do and how we go about it. Also, good graphic design is important. Edward Tufte is the gold standard author on this topic. This is one of his books. I have all of his books on my bookshelf back there. They're all worth reading over and over again. Thinking Fast and Slow, I don't have a book on that, or Influence. Both of these are pop psychology books written by very credentialed people who know what they're talking about how people make decisions. And reading through these books will give you some perspective about how to, for example, write a proposal so that it is convincing. And also when you are in the process of making, say, a requirements, a list of requirements, how you can catch yourself and resist the urge to instantiate technical solutions as requirements. Both of those I find very useful. And then this is a somewhat new book. This is for young software engineers. So if you're only a few years into this, this book covers a lot of things that the old hats learned through pain and suffering. And all you have to do is read this book, and it will take you like 4 hours, and then you will not make some very classic silly mistakes. So I recommend that you read that if you're new. We're at good. We're on time. My name is Chase Millian. There's my contact information. Feel free to email me with anything. And I thank BSSW, Exascale Computing, and the Department of Energy for giving me the freedom to work on this quite a bit over the last year. So, thank you very much.
Thank you, Chase. Let me see here. There is one question in the chat here. Mark, would you like to unmute and while I read for you?
Sure. Sure thing. Chase, thanks so much for your talk. I wanted to ask if you could summarize for us anything that you regard as sort of specific to research software as opposed to, sort of any old software project.
Yeah. I go into obnoxious detail on this in the document, and like 4 pages of detail, because it was a thing that caught my interest. I will try to state a few of the things. So one aspect is that the project management roles that typically exist in an industry context or in a larger organization or even a larger research context break down for smaller research projects, which is to say there's not one person whose job is project manager and one person whose job is systems engineer and one person whose job is developer, and so on and so on and so forth. Those are often the same person, or those tasks are shared among the same handful of people. Your customer is also ambiguous in a way, and to that end, your deliverables are ambiguous, and you have some flexibility in those. That gives you the freedom to have a little bit less confidence in your estimate, because you will have the freedom later to change course if, say, you're in the 3rd year of your 3-year project and you have these 3 papers you can write, none of which are the thing you originally set out to write. In many research contexts, that's perfectly acceptable, and it is allowed because the PI on research projects is the ultimate authority in what the project is going to be. You also have small groups of domain experts, which is to say you're going to be experts in your field. Say that's low energy physics, who are not necessarily fully qualified software engineers, which is just interesting and a thing to keep in mind. Oh geez, I had a lot of these, and I'm blanking on the list, but I have a list of like 10 or 12 different aspects of research software.
Oh, that was great. Thank you.
Yeah.
Any other questions? I invite participants to unmute and ask directly to Chase. Or write in the chat.
Some of your references, some of the books that you referenced, they were based in the on-premise world. Do you have any modern resources for cloud type development, or what's your opinion on that?
Interesting question. It had not occurred to me to draw a line there. A lot of our development in Million Concepts is cloud-based. I think the techniques do translate pretty well. If you have a specific reason for thinking that those should be thought of separately, let me know, and I can.
Well, just in cloud, you know, in reference to on-premise, you control almost everything in the development cycle. But in the cloud world, you sometimes are dependent on a lot of other third parties for their software to make yours work. And so just, you know, I'm just wondering about just, you know, sprints and cycles like that.
Yeah, I understand the question. I think that is a ongoing project management kind of problem and not an estimation problem. If you're in the estimation phase and you think those sorts of things are going to be huge bottlenecks for you, you should definitely take that into account. But managing that sort of managing the risk of that sort of thing, I think is something that you need to consider continuously while the project is underway.
Thanks. Thank you.
Janzi?
Oh, yes, I have a question. So I just don't have a good idea what could be like a research software versus like engineering. I just don't know. I want to know the, you know, clear kind of definition. Yeah. So I'm talking about this because we wrote a proposal and they consider this as a more of engineering side instead of research software. But we are both, I think this, no matter research or not, we do, you know, develop software for use. We don't want to just develop for not using it, right? If you make it stop at of like a, you know, proof of a concept level, I don't think it has a, you know, the impact it deserves, right? So I just want to know how you make your software development work appear as research instead of, you know, engineering.
I understand that problem, and it's complete. That is a completely believable kind of response from a review panel from me. So let me take it in two parts. First, how I define research software is any software developed in service to research. I know in some contexts there are more specific ideas about what research software is, like if the outputs of the software itself are the objects of study, then that is research software. For my purposes, it can be an Excel macro if that's what you need to conduct your research, and it can be you know, it can be your multi-physics model that you're running on an HPC system, if that's what you're doing. So my definition of research software is very large and probably contains things that your review panel would consider engineering. I think a critical part of research software as opposed to engineering, and this I pulled up my document. This is also a response to the earlier question. Is that the work itself around the software is exploratory and novel. So you don't necessarily, for like an engineering task, you have fixed deliverables that will not change and fixed requirements and a fixed context and a fixed knowledge base. So there are things that are sort of set. I mean, they all wiggle, but in a research context, it's sort of all up for grabs. You're going to start writing the software, you're going to learn something new about the data or the context, or some new question is going to come in, and everything is going to shift. And that's a property that exists less often in industry or, I guess, engineering context. How you convince the second part is how you convince the panel of that. I do not know. At least I do not know in a way that I can communicate, because that comes down to just the art of persuasion, making the argument, what we call proposology, trying to sort of head off every possible objection that this anonymous panel of your peers with unknown backgrounds may have. To the earlier question about the properties of research software, it's important for this estimation process that the work is novel and exploratory, because so many estimation methodologies rely on historical information about having done the work before. So you can imagine if you're if you're a website company and what you do is create websites for clients, over a few years, you will now have hundreds of examples of creating websites, have so many pages and so many links, and the database is this big. It takes us this long to produce. In research context, we rarely have that sort of historical information. Even if we do, it's minimal. There, you might have done one thing previously that was similar. So for that reason, that immediately eliminates like a huge fraction of the good estimation strategies that you might deploy.
Yeah, thank you very much. That's really helpful. Yeah, thank you.
Any further questions? We have a couple of minutes, I think, or more questions, if any. Mark.
Sure, real quick. Are you often using this approach in a sort of competitive bid process to competing with other organizations for funding to tackle a particular problem?
Yes, it's happening more. So historically, we've been writing research proposals where at least in NASA world, I don't know how it is for other agencies, but in NASA world, the review panel actually doesn't see the total budget, so that's not part of the review. So there's less pressure to keep the cost down. In like the government bid contract world, we have made the decision as an organization to not play the game where we try and get the bid as low as possible so that we can get the work. We actually ask for the amount of money that we need to do the work well, and we explain in the bid that we have done that and that we will do the work well, and we have a track record of doing the work well. And so far, that approach has been successful for us. I imagine we will get burned by it at some point, but to date, the people making those decisions have understood if you want certain things done well, it is going to cost more money. So we've made a decision to not compromise in that aspect.
Well, let me ask you this question. Don't most government agencies have an obligation to take the lowest bid, or at least consider the differences in the bids before they finalize? To just say you're going to charge more, how does
it? For the bids we have applied to, cost has never been the sole factor that they use. They'll tell you the criteria on which they will judge the bid. And for the bids we've applied to, it has always been a combination of cost, anticipated quality of the work, and the track record of the contractor. So in that combination of things, we've always done well. Again, I expect it to burn us at some point, but it's not universally the case that they have an obligation to take the lowest bid always.
I just know it's, in my experience, some customers, some partners that have done that strategy, they've either had, that done have low to win, they've done low bid, then they've done like these IDIQs to, when the project needs more money. And, I've just seen different strategies people use to win.
Yeah, that is a strategy that I am disinterested in. I would rather ask for the resources I need up front and be able to guarantee that we're going to deliver something good. And if we're not able to deliver something good with the resources that we're given, then I don't want to do the project. I would rather not do it at all.
Thank you for your comment.
Any further questions? Thank you very much again, Chase.
Thank you.
And thank you all for joining us today. I just pasted, put in the chat, the next webinar in the series will be in about a month, and it will be about software packaging. Thank you all for joining us today.
Okay, thank you.